Hey guys, my name's Josh from National Instruments. I'm here to talk to you about a little project that I've worked on using the myDAQ. The name of my project is myE-Field. So in most engineering degrees, students have to learn something about the basics of electric fields, and there's quite a popular experiment to do that. You get two metal plates and you mount them on a conductive surface, and then you charge one of the plates to some voltage and leave the other one at 0 volts. And then when you put these both on the surface, you'll have an electric field between them. And typically what you'll do is you'll get a multimeter and you'll literally measure the voltage at different points on the surface. And it's kind of a good way to get a visualization of the electric field that's there. But typically it takes quite a long time to do that, maybe up to 3 hours, and it's not the most fun experiment. So what I've done is I thought I could try and improve it a bit using myDAQ. I thought I could try and make it a bit easier as well, and maybe help the students kind of get a visualization of the electric field as they're measuring it. So let's go and have a look. Alright, so here's the actual myE-Field kind of hardware that I've made, and I'll explain what each bit is now so you can understand it. So we've got two metal plates there, and this top one will be charged to 15 volts and the bottom one is charged to 0 volts. This black surface here is actually conductive paper, so that's paper that can actually conduct electricity. The paper's got quite a high resistance, but it still allows us to measure voltage. So the idea is we'll get decreasing voltages from here to here. I've made a base out of perspex here. This is just to hold the whole thing together, and I've got a probe as well, so I use this probe to measure different areas on the paper. I've got a button and an LED. And in this project I'm using them to kind of trigger a measurement, and then the LED is there to say when it's measured something. And then of course the myDAQ, which is kind of doing everything. It's measuring it and it's outputting signals as well. And that's connected to my computer, and it allows me to take the data in and use LabVIEW to analyze it. So I think the best thing to do now is actually show you it in action. Hey guys, so here's the VI that I've written for this project. And this is where all the data is passed up. So let's jump straight into it and run it. The first things first, you'll see this page here, which just gives you an introduction of how to use it. So when we're done with that, we go on to this tab, Measure the Electric Field. And when we're ready, we click Start Test Sequence here. Hopefully you would have just noticed, but this LED right here is just flashed twice, and it's done that to indicate that it's ready to start measuring. So here's how we do it. We take our probe, and then if you look very carefully, you'll see there's these points along the paper. I've actually drawn them in pencil, and pencil's good because it conducts electricity as well. So the idea is, we put our probe on one of the points and then press the button. The light goes off, and then it flashes when it's taking a measurement, and you'll notice there's a blue bar on our electric field display on our computer. So the blue bar, or the blue colour, sorry, corresponds to 0 volts. If we then take another measurement here and press the button, it takes a measurement, flashes twice to tell us it's done, and passes that data up to the computer. So the idea is, you keep doing this for every point, and you'll notice here as I go between the plates, the field is actually going to get stronger. So you'll notice the colour will go closer and closer to red. So if we keep going here, you can see the electric field being built up on our screen on the computer. So here we go, as we're getting closer to the 15 volt plate, the colour is getting more red. And then if we go here as well, we can finish the linear portion of the electric field. There we go, and there's one more there, just hidden up there. So there we go, we've got a linear electric field, but we haven't got any of the field around here, and you'll find when we measure it, it actually doesn't behave in a nice linear fashion. So what we do, we look at these diagonal points here, and they're all numbered. We put our probe here and we measure. Now what it's done is it's measured that voltage, but it's also interpolated the voltages between it, so it's kind of predicted the voltages. And the reason it does that is basically to make things, you know, quicker and easier. It's valid because this is kind of a symmetrical electric field. If this wasn't a symmetric electric field, we couldn't do this. But what we can do is measure these points now, and you can see the electric field. You can see how it behaves around the edges. So there we go. this one, and then the final one here. So there we go. We've measured the electric field and we can see it on our VI here. We can then click electric field mapping complete, and then we've got the option to export the data into Excel. So hopefully that's made sense to you, and you know, it's kind of a nice alternative to sitting there with a multimeter for 3 hours and reading voltages. Well, thanks for listening guys, and I hope you like my project.